Bonjour. Hello. Those animations are stunning. Uh, Welcome to my talk about Kotlin, the new and noteworthy, all the things new about Kotlin. My name is Anton. I'm a developer advocate at JetBrains in Kotlin team, and I'm going to talk about some new features that I think are noteworthy. As you probably know, Kotlin was announced as a general purpose programming language in 2011, and it has done a long way in the evolution now, so it's almost 15 years old now. And it was announced as a general purpose statically typed object-oriented programming language with type inference. There wasn't any statement about Android development, but a lot of people think it's a mobile programming language due to some circumstances that happened later. But first and foremost, it's an alternative programming language on the JVM platform, interoperable with Java. Just for me to know, how many of you are Kotlin developers here? Almost everybody. Thank you very much. So we probably love Kotlin and want to know something new about it. So normally, if we were in a smaller room, I would ask you what are your favorite features in the programming language, and I do speak a lot to people, and they generally mention null safety as the single most important feature. Give me a yay if you agree. Yay, perfect. Coroutines, not so. This public is split, right? Multi-platform, well, just for some. And actually, the most emotional part is usually the syntax. Syntax is what people like the most, and when you ask about like a single feature, they usually, if they didn't think about null safety in the first place, then they're like trying to pick up like what was the most interesting syntax feature that they had in mind. So, but I'm selfish today. I'm not gonna ask you. I'm gonna talk about my favorite features, and they might be surprising to some of you. So we quickly talk about them. 10 years ago, if we had to start explaining Kotlin to Java developers, we would say, hey, we have data classes. Not so impressive today, because Java has pretty much the same feature in the language, syntactically, semantically slightly different, but we talk about syntax now. Kotlin still have a lot to offer, and it's not immediately obvious what features are there that are not existing in Java, but we have a documentation page that we are trying to keep up to date, and soon this page will have a lot more items, and you gotta check that in the documentation. I'm not gonna list them. But it was very easy to start with Kotlin from day one. Like that was the syntax in the beginning, you know, like no extra ceremony, no extra types that you have to type on the left-hand side, semicolons, new keyword is missing, string templates are there from day one, templates in expressions. With expressions, we have top-level functions. They are extension functions as well. That is something that a lot of people like. Also kind of controversial feature, but I do like that a lot. Single expression functions. When you have a single expression, you can just rely on type inference to infer the type of the return type of the function. The default arguments that are very convenient in combination with 9 parameters that result in 80% of, diminishing 80% of the use cases where you need to implement function overloads or constructor overloads. Trailing lambdas, that is a neat syntactic feature that allows us to express us more concisely when you need to pass lambdas as parameters. Nullable types, we already talked about them. Nullable types are not very sufficient if you just don't give extra tools. Therefore, we have special operators for convenience. And when we start using a lot of those interesting language features together, not one by one, but together, we sometimes get to something that is called type-safe builders, or as we like to call them, domain-specific languages, which allow us to describe declaratively some structures, object structures, configurations, and so on. But and this is my ultimately my favorite feature in the language. The notable thing about DSLs is that before Kotlin, a lot of languages that allowed implementing DSLs natively were dynamically typed, and therefore, in many cases, it's only the author of that domain-specific language that know how to use it properly. In Kotlin or other statically typed languages that allow this kind of approach, the compiler supports you, guides you, provides extra safety, warns you if you did something wrong, then it's a little bit more safer to implement this kind of constructs and easier to use. So there is more, and the conclusion out of this is that it's important how the features combine together. How can you use the individual small conveniences that result in something bigger in a safer manner, of course. So if you look at the evolution of the language today, and there are some features that are has been seemingly forever with the language, but actually if you check, they were implemented after 1.0, like coroutines, inline value classes, trailing comma, functional interfaces, and so on. They were all added after 1.0. And there is more, and there is more, and the list goes on. And well, a lot of the language features were added not accidentally, but during the experimentation when we were adding one feature and designing the other one, and then we discovered something that could fit there as well. So there wasn't like a predefined process for the evolution of the language, and therefore a lot of features appeared ad hoc, which leads us to an interesting situation that in 2020, when I joined the team, I received this interesting T-shirt with all the dates for the release scratched out, and that was a clear indication of a technical depth that appeared over time. Obviously, the team was aware of that and already started a project called K2 that was aimed at rewriting part of the compiler for better evolution in mind and also for better performance. But why would you undertake this kind of a huge project? It was a huge undertaking. It took 5 years to actually deliver. When you already have something working and a lot of users behind it, why would you rewrite something from scratch, and why would you not evolve just slowly over time? So why? The essence of it is that the first version of the compiler was a prototype. So in 2011, when the prototype that was shown at the announcement at the JVM Language Summit was actually a prototype, and normally you should throw it away right after the announcement, after the concept proof, and re-implement it. But it was shipped because the team was eager to move faster. And well, it comes at its own price. So a lot of features appeared unexpectedly, not that we had 10 years of evolution in plans for the language and all the features written out. But during the evolution, well, a lot of features appeared ad hoc, as I said, and it made it harder to maintain the compiler. The interaction between the compiler and the IDE is a very specific thing. It's a different thing to compile your program and to use the compiler inside the IDE. And we want the language to have a very good support in the IDE. So the difference is that when you just compile the program, right, it analyzes the whole program, and when you type something in the IDE, you just work with a single code snippet, and you want all this to be responsive, syntax highlighting, auto-completions, refactorings, and so on. And the program might not be always completely correct, so therefore the two use cases are completely different. And the compilation performance is something that we were concerned about, and you cannot really be satisfied with it at any point of time. And Kotlin needs to do a lot more work than the Java compiler, because it compiles both the Java code and the Kotlin code as well in a few cycles. And the language features actually come at a cost as well. So in 2.0 last year, we re-implemented the compiler and announced it. And there were a few consequences. A lot of small features were corrected just because we re-implemented it. And we improved the performance. That was the main goal. So when we enabled it on our CI server for IntelliJ IDEA monorepo, we slides off about 40% of the compilation time. And that's only due to the new compiler. So the result of this work was that the frontend was re-implemented with the new goals in mind. And I will not go into deeply into the compiler theory, of course, but the interesting result of it was that the parser now produces something that is called frontend intermediate representation that can be fed into an analyzer on the next stage. And when analyzer performs its work, it will feed the result into the backend that will generate the platform-specific code. So the intermediate representation is kind of a desugaring of the construct that you see in the editor before the analysis phase. And when the sugaring is happening, it will produce something that is similar to a syntax tree, but also with some metadata. But the way you should think of it is that it's a desugaring phase. To rewrite some of the statements like if conditions, for instance, or if statements, if expressions into a common form that is a when expression, or rewrite the for loops into iterator loops, and desugar some of the special syntax constructs into something that would look more Java-like. The result of this is that we can analyze this intermediate structure, and due to desugaring, some of the bugs or issues were corrected kind of automatically. For instance, here, not that it's a very representative example where we use the mutable list as a parameter, but we want to mutate the first element of that by incrementing with 1. And here we have a long, the element that is a long inside this list combined with the integer literal type, which is a perfectly valid situation for an application level programming language and should work, and it works. But if you replace that with another operator, which is basically an equivalent, that led to an error, or the compilation error in Kotlin 1.x, and after 2.0, thanks to desugaring phase, it became correct. The semantics is preserved, right? So there are more complicated examples that we can bring, and thanks to desugaring, they are fixed as well. But we will not dive into what was implemented too much. Let's proceed further. The other feature that existed basically from day one as well in the language got a bit more powerful thanks to this new data structure. So smartcasts, I hope you know what smartcasts are. Please raise the hands. Yes, most of you. So smartcast is something similar to instance of check inside in Java, where we check for an instance, and then we can just use that variable that we just checked as it's of an instance of that class that we checked with, and it's called a smartcast. It's a nice feature. It's a great convenience, But it was very limited in the implementation because we didn't have a meta information anywhere in the intermediate representation of the syntax tree. Now, therefore, this kind of situation wouldn't work if we extracted the variable into, or the condition into a variable. But in 2.0, we have some special place in the structure that carries along the information, and then therefore this feature just works. In fact, it works in many more places, like here, for instance, a slightly more complicated example where we have a more sophisticated check that is assigned to a variable as a result, and then we use the same class somewhere inside the method body. So what is happening there is that first we have an instance check from any to a card instance. If it succeeds, then the right-hand side of the expression will display that there is a smart cast happening from any to the card. And then there is a null, is null or empty function that is being called on the holder field of that class, which if it succeeds, then the latter will just be smart casted from the nullable string to a string. Now, maybe you haven't thought about it, but how is it even possible that if the holder is a null, why is it even possible to call an is null or empty check on that one without getting a null pointer exception? There are no answers probably, but if we check the implementation, we can see that it's possible to implement an extension function on a nullable type, and therefore inside that function we can do this null check, and thanks to the contract that is described inside this function, the information about succeeding for the null check will give the compiler a sign that after calling this function, the field is not null anymore. So therefore, we can see that after the null check, or is null or empty, the function call, the card holder is okay to use. So I find it fascinating that through many different checks, we can actually cast this variable or the inners of this class into something that is a string in this case, of course. And well, you can imagine that this kind of data flow analysis triggers everywhere in even more complex situations. So we have a new compiler, but what's next for Kotlin? So currently, the language is developing in two main directions. First of all, since it's a data world, we work with data in the applications, and we see a lot of trends going there as well, that we work with data. We want to give the developers more sophisticated tools for that, and therefore we are looking into ways to improve the syntactical capabilities as well as the compiler to support this kind of work. The other direction is that we want to provide safer and stronger abstractions that would allow you to less mistakes when you develop the applications. So let's see. There is a roadmap. We updated that in February this year. The next update is coming in August. And one part of this roadmap lists the different features with the evolution proposals where people discuss the different ideas. The proposals have different status, and the discussions are happening in GitHub. So feel free to come and express your opinions about the features you have a strong opinion on. And well, the list is long there, and therefore I had to pick something that I feel is interesting in the context after 2.0. 2.1 has been delivered in the end of last year. 2.2, the first beta build is coming today. Hopefully by the end of the day, there will be an artifact published on Maven Central that you can download and experiment with. And 2.4, since we have yearly releases, then 2.4 is coming next year in spring. So the features I wanted to talk about today are the guards that are already in 2.1 and getting stable in 2.2, that is coming in May. Context parameters will be a part of the next release. Check return value, an interesting capability of the compiler for safer handling of the values, will be in 2.2 partially, and then it will be expanded in the next releases. And there are a couple of forward-looking features in the language that are scheduled to be experimental in 2.4 in a year, but I think it's great to talk about them now. So let's start with a simple example. I will have a lot of code in the slides because I don't want to type them. I will not have that much time. The code here is seemingly like simple business code. We are getting an order, then we are checking the order for an instance, what type of order is there, and some conditions as well. Works great, but slightly verbose. There is some repetition and potentially a logical error on the same code. What happens if the yearly subscriptions amount is less than 100? This situation doesn't cover that. So, and we can have even more different types there. So an obvious solution would be to use when with subject expression that can exhaustively check for the types if we checked everything in the hierarchy, but then the condition doesn't work for us syntactically, and therefore something that is called guarded conditions was introduced into the language, first as a beta last year, and now it's getting stable. And well, it's good to be shipped. It's like something that people like. It's also supported by the compiler, so that if you reorder the conditions there and some branch of it is not reachable, then the compiler will warn you about that. As I said, it's not already there and it's getting stable in 2.2. But there's always a lot of questions when we add a feature in the language. Well, you are adding something and then maybe you should add something else, and Java added pattern matching and Scala has something else. In Kotlin, we try to solve the minimal surface of the problem that we have. So for pattern matching, instead of implementing the pattern matching in a full way, we actually have destructuring. So the way we talk about guarded conditions is it's a pattern matching without binding. Instead of binding to variables, we have on the next statement within the block of code that matches the condition, you would use destructuring in order to bind the variables from the instance that you check. But it has also problems. So for instance, in this example here, like suppose I'm checking the yearly subscription for something, and I destructure this object this way, and then it prints order 1, my name, and something else, some amount, right? The thing is, if I change the order of those variables that I just declared on the left-hand side, this will lead to an interesting logical error, but not a compiler error. So because the destructuring is positional, and positional destructuring can lead to some of these funny, interesting problems during refactoring phases, program evolution, whatever changes you make to it. You might not notice this kind of change. So the funny thing here is that the name and ID are switching places when I'm destructuring the object, but the compiler will not warn me about that, because I can give any names to those variables. So what we need here is to is the compiler to say that the name doesn't match, but the positioning is the structuring is positional, so therefore the names are not checked. So what we are looking at is introducing position-based, name-based destructuring instead. However, the problem is that we have already an existing syntax for destructuring with a predefined semantics. So we cannot just say that now we are checking the same syntax differently. This will, have some effects on backwards compatibility, of course. So what to do here? And team has something else in mind. So a new syntax where you that is very similar to the previous one, but you have to explicitly tell that the every single variable in that list is a val, and then the compiler would actually tell you that the name doesn't match. The interesting effect of this is that we don't need data classes anymore for this feature to work, because the previous positional destructuring relies on so-called component functions, component 1, component 2, component 3, that are generated during the compilation for every element in the data class. The name-based positioning destructuring does not rely on that, and therefore we don't need data classes to be used for this feature to work. That's a great effect. And this feature is scheduled as an experimental in 2.4, which we will have to wait a little bit, but it's for great good. There will be an interesting process of phasing out the previous syntax and probably reintroducing it again with a new semantics. So it's a slow process, but it will be interesting to watch how it works out. I'm talking about those features that I have on the list, not in the order of they are written out here, but somewhat randomly. But it just supports the logical flow of my talk today. So one feature I want to talk is the context parameters that is going to be introduced in 2.2 soon as a beta feature. I told you about my favorite feature, the DSLs. And when we use that, like this is a very simplistic example here. We have a class, and normally we build that class using those DSLs. So we build an object graph, and the central feature of this process is the ability to describe parameters that are called formally in the documentation. You will find them functional literals with a receiver. So technically you can create extension functions, you can create properties that are extension to existing classes, but you can also declare lambdas that are extensions to some type. And this is a central feature for type-safe builders. So this code would normally be something like a DSL library that you give to your users, and then they use it with a convenient syntax in their applications to build instances of those objects. As you can see, we are assigning a couple of properties, the name, Bob, and then there is like every good person needs to have a birthday, right? So we assign a birthday field there, or a property. And the syntax there doesn't look really nice. Like we have a nice DSL, but we are using some APIs directly that might not look nice. 2003-10, is it the 3rd of March, 3rd of October, or 10th of March, and so on. Inconvenient. So we probably want this some interesting functions to support our DSLs. In this case, I could do something better and introduce an extension function for an integer that would allow me to describe those needs or express something inside the DSL scope. This function would be provided by the DSL library, but the problem here is that since it's introducing the new function to a global type, we can use this function now inside the DSL, but also outside the DSL. It's not nice. It basically causes the scope pollution, namespace pollution, we can use so the function becomes global for an integer type, and this is something that we don't want. So can we do better here, and how can we restrict the scope of this new function? And one of the use cases for context parameters is to require something to be present in the context for a function to be used, and then the compiler will be able to check if this function is eligible to be used within the block of code. So we can annotate this function using this context annotation syntax, and then require this context to be present for this block of code that will be used as a parameter to the function. And the library author is then responsible for providing this context. It can be like one context, many contexts, like maybe it should be a database context, should be logging context, and so on. So in this case, we're going to say, well, this new function is eligible to be used within the client builder library, DSL, and we are providing this context ourselves. And therefore, the compiler will be able to check if the function is being used in the correct place, and if it's outside of this correct scope, then it will be a compilation error. So this is one of the directions where Kotlin is evolving, providing safer abstractions and more checks by the compiler. It's going to be a beta status in 2.2, so you're going to be able to play with that already this evening. The next feature I want to talk about is actually something that is related to handling errors in Kotlin. So just to clarify, errors are not exceptions. This is not something that's related to a control flow, but rather to a type system. It will be experimental in 2.4 in a year, and let me explain that with this toy example here. Today, we might use nulls as errors to indicate that something didn't succeed. You probably remember a standard library function called is first not null or null, something like that. There are many nulls, right? So for instance, we are fetching the user, fetching the JSON from somewhere, from the network, and then we are parsing that JSON and then creating an instance of that user. And both functions can return a null, either due to the network error or parsing error. And when we use that, we might chain those calls to get a user. As you can see, we have chaining. It's convenient. Then there is a type safety because it might return null. And well, the compiler forces you to check something for the null. And then smart casts are triggering again. Cool. But the problem here is that there is no distinction between the two kind of situations where we have nulls, right? We have a network error or a parsing error. So how people deal with that today? They might introduce some sealed hierarchies to kind of give a meaning to those nulls instead. So this would result in this kind of mapping. When you call a function and it returns a null, then you just map that null on something that is in the sealed hierarchy, and then on the user side, you will be able to exhaustively check for the results and clearly do something as a result. So looks nice and safe, but extending this kind of sealed hierarchies is kind of painful. The verbosity of it, well, probably a matter of taste, but it looks like the code is getting more verbose, and it also causes some nesting depending on the complexity of the sealed hierarchy. And it also might be a matter of taste, but the language team in Kotlin is very keen on reducing the nesting in the code. The other way is to use something that is called the result type in the standard library. It's this kind of approach would allow for better extensibility, but there are functional operators that some people don't like, and we are losing the exhaustiveness on the when checks. So back to the original example again. What could we do better here? So if we had something that would clearly allow us describing the errors in the program, that would actually improve our situation. So this is something that is coming to, currently is in the design phase, and we are aiming at adding the next year. We can indicate that some object or a class is an error, is a new kind. And then how the code would look like in our example is that we would indicate that the method can return a value of some kind or an error. So on the user side, we would still be using the same syntax, basically, the same approach for writing the code. We can still use the chain calls. We still would get the type safety from the language and support from the compiler that we didn't check for something. You see there is an error, then, well, you have to check the value. And, well, it's pretty linear as well. But the result of it is that you will you will be forced into rewriting it in a slightly different style, and which will lead you to this more safer way of using the language with when expression that is going to be checking your values exhaustively. So as you can see, errors are the types, but they are kind of values as well. But what about exceptions? We are talking about the types and values, but in Java, and we know that Kotlin is interoperable with Java, and in Java we have checked exceptions. Any error, any Java code might throw something, and then we kind of need to map it somehow to an error to be used in Kotlin function. So there will be something that is provided by the standard library, technically a try-catch block returning an error in the an error class that is coming from the standard library, and then you can actually map it into in your user code just using this function, map it into an error. It would be nice to see if we can somehow ergonomically to have support for checked exceptions so that the compiler will warn you that you need to handle this invocation that is coming from Java and might throw an exception. But it's not in the list of features yet. So let's talk about the last feature in the list that is also adding its value into the compiler safety, and we'll make the language safer already from this release. So here's an example, seemingly a simple one and should just work. And if we execute that, we actually get an exception. And seemingly it's a simple function, and maybe you have spotted the bug already, but it might not be obvious on the first glance. So how is it possible? Well, we simply forgot a return statement. And if we execute this function, we actually get a proper result. Interesting. Why didn't compiler help us here? Here's another example. We are passing a mutable list. We call a function on that list, and we want to get two smallest numbers in that list. So the first one and the second one. And the result is 41 and 15. And if you look at the initial list, obviously it's not the correct answer. We can see that 4 is clearly smaller than 15, for instance. So why is this bug happening here? Well, because of the way the functions are declared in the library and the type hierarchy for the collections. So there is a sorted function for the that can return a value, and there is a sort function that is not like returning a value. So instead, like we were using something that was returning a value, and we should have used the result instead. And the fix for this would have been that we should use an in-place sort function to get the correct result here in this situation. And the compiler also did not help us with this one. So what those two examples have in common? They both do not use in any way the result of the function that we just called. So is there a way to prevent that? Well, we could, and some IDEs and checkers actually provide that. We can just say that let's report all the values that are not used in the program. And well, this might lead to something that is just a warning hell. All your code is covered with yellow, and too impractical, because it's not always true that you can check that you have to check every return value, because like there are examples in the standard library, in the language, in your programs, that a function may return a value, but it's not meant to be checked like always. It's optional. So there are existing solutions for this, and for instance, error-prone library provides this check return value annotation, or detect also has the check result and check return value annotations like that you can enable for the static analysis in the linter, and then during the build execution they will be reported, or like you would check the reports from the CI server. How many of you are checking the CI server reports after every build? Probably not too many, so you want them in the editor, of course. So what will happen now in 2.2 is that first, the standard library functions and the Kotlin X libraries will be annotated with an extra must-use return value annotation, and this will be opt-in. So if you want to take the advantage of extra checks by the compiler, you will opt in this language feature, and then the compiler will check if you are consuming the values that are returned by the standard library functions or Kotlin X libraries, and warn you about that. And the next steps would be to introduce this support for any libraries that are not in the standard, like not part of the Kotlin X library family, and also allow that for the application code by default. And well, this way we actually give the tool to the library developers or function and API authors who will be able to say that the result of this function call must be used in one way or another. This is somewhat in line with what we have in the language already for null safety, that a function can return a nullable type, or the reach errors that are coming in a year, that the function call might return a real value or an error, and then you are forced to check like if it's an error or not. So this is it's a consistent addition to the language, and will give more flexibility for the library authors to provide a safer API surface in their libraries. So this is the list I was talking about today that I could fit in my presentation. I could add more, but you gotta check the roadmap and stay up with the news that are coming this year for more features that we are adding into the language. Just to sum up, so we have the new smarter compiler that provides this new data structure that allows for smarter checks in the compiler, and we are building more features for working with data and stronger abstractions in the compiler itself, supported by the language features. So if you want to check the slides afterwards, I have them on speaker deck. Please leave some feedback for me to know if you liked what I was talking about or not, or if you want to know more about the language, follow me on Twitter as well. Thank you very much for coming, and it was a pleasure to talk to you. If you have more questions for me or my colleagues from JetBrains, we have a booth at the expo. Please visit us there. Thank you.